All right, we are continuing with partial fractions. We're going to do example 3 and example 4 today. So example 3 deals with distinct linear and quadratic factors. So in this case, we have 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4. So I'm going to go ahead and factor that denominator. So my fraction then in factored form, let's see, I'm going to factor out an x of that first one, so I get x times x minus 1, and then x squared plus 4 does not factor, so that's a unfactorable quadratic. And in this case, when I set up my partial fractions, I want constants above the linear factors, so a constant above x, a constant above x minus 1, and then I want a linear factor. So I'm looking for cx plus d, where c and d are constants, above that quadratic factor x squared plus 4. So then I'm going to go through and multiply by my least common denominator, which we know is x times x minus 1 times x squared plus 4. Cancels all over here. So then I am going to get that 2x cubed minus 4x minus 8 equals a times x minus 1 times x squared plus 4 plus b times x, I don't need to put that in parentheses, and then times my x squared plus 4, and then I'm going to have cx plus d all times x minus 1. Okay, so I have a whole bunch of gross things here. So instead of factoring this all out, combining like terms, which you could do, I'm just going to go ahead and plug in values for x to kind of try and eliminate some of those terms and make it easier. So the first thing I'm going to do is I'm going to let x equal 0. And so then I'm going to get negative 8 on the left-hand side. And then on the right-hand side, I'm going to get a times negative 1 and then plus 4 and then plus 0 because I have an x factor in both of those second terms. So then if I solve this, I get negative 8 equals negative 4a, or a equals 2. All right. So now I can use that value if I wanted to, or we can go through and we can figure out what else I can plug in. So if I let x equal 1, then I can see that this factor and this factor will be 0, and that will let me find b. So for my next one, we're going to let x equal 1. So then I'm going to get 2 times 1 cubed minus 4 times 1 minus 8 equals 0, because that term will go away. Then I will have b times 1 times 5 plus, and then that will go away because I have that x minus 1 term on that last chunk there. So when I do this, I get negative 10 equals 5b. So then I get b equals negative 2. So at this point, we have c and d yet to be determined. And so we can find these remaining constants by choosing 2 other values for x and solving the resulting system of linear equations. Okay, so you're going to get a system of linear equations here, and you have to pick 2 values of x we haven't picked yet. So I'm going to pick x equals negative 1. And we already have that a is 2 and b is negative 2. So we're going to let x equal negative 1, and we know that a is 2 and b is negative 2. So if I plug this in, I'm going to get negative 6. I'm kind of doing some of the math here in my head as I write this. Equals 2 times negative 2, and then we have a 5, and then plus, and then I have that negative 2 for b, negative 1, and then a 5 again, and then plus, and then I'm going to get negative c plus d, and then negative 1 and a minus 2 all over there. So then when I solve this all out, let's see here, we're going to get a negative 20, 10. Okay, so then we're going to get a 2 equals negative c plus d. Yeah, I'm kind of skipping some steps there. They're algebra steps. You can confirm that if you want. And so that's going to be one of my systems of equations. And then I'm going to go ahead and now I'm going to let x equal a different value that I haven't picked yet. So I can't pick 0, 1, or -1. So I'm going to pick 2. So if x equals 2, a equals 2, and b equals -2, I forgot my equal sign up there. Then what I'm going to get is here I'll get 0 equals, and then 2 times 1 times 8 plus -2 times 2 times 8. And then my last term here will be a 2c plus d. And then that is going to be times 2 and 1. And when I solve this, I'll get a, let's see here, I will get, let's put all the constants, so I'll get 8 equals 2c plus d. So this is my other equation. So if I put these two equations together, I have -c plus d equals 2, and 2c plus d equals 8. And when I go ahead and solve this, oh, sorry about my dog. Philip, chill out. Okay, so then when I solve this, let's see here, I will get 3c equals 6, so I multiply the top one by a -1. And so then I get c equals 2. And then from there, I will get -2 plus d equals 2, so d is then going to equal 4. All right, so we found A, B, C, and D. So now we can go back to our integral. And so if I have my original integral, which was 2x cubed minus 4x minus 8, over, and then the factored version was x minus 1 times x squared plus 4 dx. And we're going to split that up into my integrals. So I have 2 over x, because that was a. B was -2 over x minus 1. And then c was 2x, and d was 4. And then that's over x squared plus 4. And then I can go ahead and split that last fraction up even more if I wanted to. So I could put it as 2x over x squared plus 4 plus 4 over x squared plus 4, and that's going to make it a little easier to solve as well. And so then going through and doing this, I'm now going to get that I have, let's see here. So the derivative of 2x, so here if I do some u substitution, so if I let u equal x squared, I see that that's also just a natural log. But here, the degree of the numerator for this last one is 2 less than the degree of the denominator. So this one is not a natural log. And if I look, this reminds me of something with those trig substitutions we did. And if you look on your formula sheet, this is actually an arctan. So when I go through and do this, the first one is going to be a natural log. So I have 2 times the natural log of the absolute value of x, then minus 2 times the natural log of the absolute value of x minus 1. And then here with my u substitution, I know that 2x is going to cancel, so then I get plus the natural log of the x squared plus 4. So I don't have a coefficient on that one. And then that last term is arctan. So if I look at the arctan formula, the square root of 4 goes in the front, so 2. And then arctan, and then x over 2. And then don't forget your plus c. Okay, so that is how we do that one. Lots of work there, lots of algebra, using some of those antiderivative formulas. Okay, our next one, we have repeated quadratic factors. Okay, so let's go ahead and this one is already factored. We have x squared plus 2 squared, right? X squared plus 2 doesn't factor anymore. So when I want to go ahead and deconstruct this to figure out what my partial fractions would look like, I want, since they're quadratic factors, I want the numerators to be linear functions, so ax plus b, and then I'm going to have another one since there's 2 of them, so dx plus, or cx plus d, go in order. And then my denominator, kind of like we did when we had repeated linear factors, I'm going to have x squared plus 2 without the exponent, and then I'm going to go ahead and have x squared plus 2 quantity squared with the exponent. Okay, so I want to build up that factor until I get to as many times as it appears in the original denominator. Okay, so then for this one, what I'm going to do is I'm going to multiply both sides by x squared plus 2 quantity squared, so it cancels here. And I'm going to distribute it. So once I do that, I'm going to have my 8x cubed plus 13x equals ax plus b times x squared plus 2. And then my entire denominator will cancel on this cx plus d. And then so here I'm going to go through and I'm going to expand this and go ahead and multiply it through. So I get 8x cubed plus 13x. And when I FOIL that, I'm going to get 8x cubed plus 2ax plus bx squared plus 2b plus cx plus d. And then what I'm going to do is I'm going to go ahead and do the relating the coefficients. So I'm going to have everything that has an a, b, c, or d on one side, which I already do. And then I have everything without a, b, c, or d on the other side. And then I'm going to go ahead and look at and group my things by their x values. So here I have ax cubed. Okay, so that's my cubic term. And then I have bx squared. That's my only square term. And then I have 2 linear terms. So I'm going to factor out that x, and so my coefficient on my linear term is 2a plus c. And then my constant term is going to be this 2b plus d. And then when I look at my polynomial on the left-hand side, I can see that 8 has to be the coefficient in front of my cubic term, and that 13x has to be the coefficient in front of my linear term, meaning that both of the b and the 2b plus d have to be 0, since those terms do not exist on the left-hand side. So we have 8 equals a, we have 13 equals b, 0 equals b, and we have 13 equals 2a plus c, and 0 equals 2b plus d. And so getting all of this together, we get our a equals a. We have our, let's see here. So if b is 0, then that means d is also 0, to make that true. And then here, when I plug in the 8 in for this a, then I am going to get that c equals -3. So I have 8 is a, I have b is 0, c is -3, and d is 0. So then when I go through and do my partial fractions and rewrite my integral, I have 8x cubed plus 13x over quantity x squared plus 2 squared dx. And that's the same thing as the integral of 8x over x squared plus 2 minus 3x over x squared plus 2 squared dx. Then we're going to do some fun u substitution on that second one. And that first one, the difference between my, so I'm doing u substitution on both of them. So the first fraction here, if I let u equal x squared, then I can see that it's going to be a natural log. And on the bottom one here, we just basically have power rule going on. So if you want to let u equal x squared plus 2, you can do that. And I'll let you figure out those and confirm that the answer then would be 4 times the natural log of x squared plus 2. X squared plus 2, it can never be negative, so I do not need absolute value bars there. And then over here, I have that exponent of -2, so the negatives will cancel. I get 3 over 2 times the quantity x squared plus 2 plus c. Okay, so confirm those integrals for yourself, And that would be our answer for that. So go ahead and try the